Okay. Okay. In the previous video I put in the Darsa site, uh, I I started a concept for clustering. Uh, Clustering is uh, a field in data mining. I said that in data mining we have different types of learning: supervised learning, unsupervised learning, and semi-supervised learning. In supervised learning, the data that we have, it has some inputs and outputs. And for example, in the example we had about fruits, the inputs of the fruits were the height and the color of the fruit, and the output was the type of the fruit, which was an apple or pear. Okay, so in our data we had inputs and outputs. Or for example, in the example about uh, houses and the price of houses, we said that each house, it has some attributes like the age of the house, the the number of rooms, the address, and the output was the price. Okay, so we had inputs and outputs. This is supervised learning. Supervised learning, we had it in classification and regression. In these two types of data mining, we had supervised learning. In unsupervised learning, it is the second type of learning. Our data doesn't have outputs. We only have some inputs. Okay? So it's very different from classification and regression. We have a data that it only has some inputs and we don't have outputs. So in this type of data, the type of learning that we can use is unsupervised learning. Okay, this is the topic that we will have in this slide about unsupervised learning and clustering. Semi-supervised learning is the third type of learning. In this type of learning, we have a little amount of outputs in our data, and most of our data doesn't have outputs. Okay, so this is semi-supervised learning. Okay, in this slide, we will talk about unsupervised learning. Um, uh, Unsupervised learning, yes, in supervised learning, we have our data has labels or outputs. Okay, outputs is the labels. Yes. The Okay, why is unsupervised learning important? Because labeling the data is time consuming. Okay, if you want to assign some outputs to the data or label the data, it is time consuming. Somebody has to sit down and label the data. Okay, there are many companies that their job is data tagging. Data tagging is a very important subject in AI. artificial intelligence. Data tagging is very important for machine learning, so it is time consuming. So that's why unsupervised learning is important because it doesn't need labeling. We don't need to label the data, but it the applications of unsupervised learning are not very much. We don't have many applications for unsupervised learning. Most of the uh, maybe 90% of the applications in machine learning they are supervised learning. But there are some sometimes we could define a problem and we could solve a problem using unsupervised learning. Okay, so unsupervised learning or clustering. Clustering is a term that is that it means unsupervised learning. Okay, clustering is a term that you will see uh, in uh, in many places. Whenever we say clustering, we mean unsupervised learning. Okay, clustering is learning from data that doesn't have outputs. If we have some data that doesn't have outputs and we want to learn from it, we should use clustering. In clustering, we are dividing the data into some clusters. Okay, so we are dividing the data into some clusters or some groups. This dividing of the data is based on the similarities between the inputs. Okay, so we are dividing the data into some groups based on the similarity between the inputs. That is a very general definition of clustering. For example, in this figure, you see that we have some data here, and the data could be uh, grouped into three clusters. Okay, sorry, this is the first cluster, this is the second, and this is the third. Okay, we have three clusters, and our data, it has two inputs, x1 and x2. These are the inputs of our data, x1 and x2. Okay, so our data has two inputs or two features, x1, x2, and we have grouped our data into three clusters or groups. Okay, so here our data has two features, x1, x2, and we don't have output. We only have inputs, two inputs, x1, x2. Okay, in each cluster, for example, in this cluster here, the data that are inside this cluster, the x1 and x2s are near or similar. Okay, so the x1 and x2s are similar in each of the clusters. Okay. Okay. In clustering, we have many different algorithms. Okay. In we have many different algorithms in clustering. Partition-based clustering. a hierarchical based clustering, density based clustering. Okay, there are many types of clustering. Okay, the first group is partitioning based clustering. Partitioning based clustering. Partitioning based clustering is a type of clustering which we are dividing the data into several non-overlapping clusters. It means that in this type of clustering, the clusters they don't have data which is in two clusters. Okay, non-overlapping clusters means that in each cluster the data are not uh, common. I, I mean that each data is only in one cluster and it couldn't be in two clusters. Okay, and we do this we do this uh, grouping of data based on some similarities and in an iterative manner. It means inside a loop. Most of the clustering algorithms they have a loop. Okay, they have a loop and they are repeating some tasks. They are repeating some tasks. Okay, so this is a group of clustering partitioning based. One of the algorithms in this group is k-means. K-means is an algorithm in this type of clustering. Okay, k-means is the simplest type of clustering. K-means is the simplest type of clustering. In k-means, we are dividing the data into k non-overlapping clusters. Okay, so in k-means, we have to give the number of clusters. K is the number of clusters. So we are dividing the data into k different clusters, and the clusters are non-overlapping. Means it means that they don't have similar data, and each data is only in one cluster. In k-means, each cluster has a cluster center. Okay, each of the clusters in k-means they have a cluster center, and uh, this is very important. And in k-means, the cost function is the distance between the data and the center of the cluster. In most of the machine learning algorithms, uh, we have some cost functions. You remember in classification, we said that the cost is defined usually with error or risk, the risk of classification or the error. Okay, here again, in this clustering, the cost function, it means uh, how do we how do we say that a clustering is good? How could we define that? Okay, we could define that using this cost function. Okay, we do the clustering that minimize the cost function, and the cost function is the distance between the data and the cluster centers. the distance between the data and the cluster centers. Okay, so this is k-means. K-means, this is the uh, main features of k-means. We have to know the number of clusters, which is k, and each of the clusters, they have a cluster center, and you have a cost function. The cost function is guiding the clustering algorithm. Okay, the cost function is a function that it guides the clustering algorithm. Okay, and this is the algorithm of k-means. This is the algorithm, and in this algorithm, we are selecting k instances. The first step of the algorithm is that we should define the initial cluster centers. Okay, okay. We said that in k-means, each of the algorithms they have some cluster centers, and we want to define the initial cluster centers. Okay, we select k instances as the okay, we select k instances randomly as the initial cluster centers. Yes, the cluster center, as you will see in the algorithm, okay, in the first step, it is selected randomly, okay, but in the algorithm, the cluster center is the average of the data inside that cluster. Okay, when we get the average of the data in each of the cluster, the average is usually in the middle of the data. Okay, so the average of the each of the clusters, this defines the cluster center. Okay, so the first step is selecting k. Okay, if for example we have 100 data, okay, if we have 100 data and we want to cluster this data, and k k is for example free. Okay, we want to uh, group the data into free groups. So we have 100 data and we want to group them into free groups. Uh, okay, then we select we select randomly from this 100 data. We select free data randomly. For example, we select the data number 20, 55, and 90. These are the free data that we have selected randomly, for example, and this free data would be the cluster centers, the initial cluster centers. Okay, then we enter this loop. In this loop, for each data, we calculate the distance of each data to all of the cluster centers. Okay, if I have 100 data, I calculate the distance of all of the 100 data to the free cluster centers. Okay, this is the first step of the loop. And then we we put the, we put the data into the cluster which it is nearest to the cluster center. Okay, okay. Look at this. You see CI. CI. It means the cluster of data number I. Okay, CI means the cluster of data I. CI equal to argmin. Okay, this is the distance between xi minus mk. Mk is the cluster center of the cave cluster. Okay, we have uh, K cluster and mk is the cluster center of the cave cluster. Okay, okay. You see here the indexes of the clusters. The indexes of the clusters are from 1 to k. Uh, I'm sorry. I will be back in 2 minutes. I'm sorry. Okay, I'm sorry for. Do you have my voice? I'm sorry. Okay, so CI, it means the cluster of data I, and each of the data are put in the cluster which they are nearest to the cluster center. Okay, here we have n data. For example, n is 100. We have 100 data, and we have k clusters, capital K. Okay, capital K, and k, small k, is the index of the cluster. Okay, so we put all of the data into the clusters, and the final step in this loop is updating the cluster centers. Okay, each of the cluster centers, they are updated using this formula, and the cluster center would be the average of the data inside the cluster. Okay, so, and this loop is repeated. This loop is repeated, and in every time it is repeated, the cluster center is updated, and the data is uh, assigned to the cluster which it is nearer to the cluster center. Okay, this is the logic of this k-means algorithm, and this loop is repeated until this condition that it says that we don't have change in the cluster centers. Okay, so we uh, we are updating the cluster centers in this loop, and then we are putting the data into the clusters. Okay, when we have updated these cluster centers, then again we have to calculate the distance to all of the cluster centers and put the data into the cluster which it is nearest. Uh, and this uh, loop is done until uh, we see that the cluster centers are not changing. Okay, so if we don't see any change in the cluster centers, it means that we have gone, we have come to the final situation. Okay, let's see this in some examples. The k-means algorithm. Okay, you see here we have some data here. These are our data. Our data has two inputs, x1 and x2. Okay. The first step, as it has been stated here, is random selection of k centers. In this example, we have assumed that k is 2. Okay, k is 2. We have two cluster centers. Okay, so as you see here, this data and this data, they are the initial cluster centers. They are selected randomly, these two data, this data and this data. Okay, do you understand? Okay, so these two data are the cluster centers. Okay, then this is the first step of the algorithm, and then we calculate the distance of all the data with these two data. And then we have two clusters, I said. Okay, these data, they are nearer to this cluster center, and this data in this cluster, they are nearer to this cluster center. Okay, and in the last step, of the loop, we are updating the cluster center. Okay, you see this plus sign here. You see this plus sign. This plus sign, it is the updated cluster center. Okay, the plus sign is the updated cluster center. Okay, so in the next step, again, we repeat the loop, and we see that these data, they are nearer to this cluster center, this, and these data are near to this cluster center. So we have new clusters here, and in the next step, at the last step of the loop, we are recomputing the cluster centers. Okay, these two plus signs, these are the new cluster centers. Okay, so, and again, we repeat the loop. We put the data into the clusters, and in this time, we see that the cluster center that we have computed, they are the same as the previous one. Okay, you see the cluster center that we have in figure, now in figure G, it is the same as figure E. Okay, you see that the cluster centers in figure G is similar to figure E. They are the same. So we this is the final step of the algorithm. This is the final step of the algorithm, because the cluster centers didn't change. They are the same. So we stop the algorithm. Yes, here we are updating the cluster centers, and it's like learning, as I said, in classification, we are doing some learning. Okay, and it is unsupervised learning, and we don't have outputs. In this type of learning, we want to just group the data. Okay, and you said that is the number of centers equal to the number of outputs. Okay, uh, as I said, in clustering, we don't have outputs. We don't have outputs. Okay, uh, but but sometimes we use clustering as a step for supervised learning. What do I mean? I mean that if we have some data that it doesn't have outputs and it only has inputs. We could do a clustering. We could do a clustering and then use the clusters as the output of the data. And after that, we do supervised learning. For example, we do classification. Okay, do you understand, Mr. Bassett? But the original data doesn't have outputs, but we are putting some outputs using the cluster. Okay, thank you. Thank you, Mrs. Noura. Mrs. Noura, thank you. Yes, as I said, clustering and classification could be used together. Yes. When, if, okay, okay, we have some data that it doesn't have outputs, and we could assign the output using clustering. We could give it some output, and then we could use classification. Okay, but but uh, but usually we don't do this because the output that is given using clustering, it is not very accurate. Usually uh, the outputs are assigned using uh, a human expert, but this could be done. This could be done. We could do it, and maybe in some applications we may have good results. This is something that we could do. We could give the if in our data we could give some outputs to the data, and then uh, we could do classification. Okay, in k-means, this is an example of k-means. Again, here you see we have 8 data, A1, A2, A8, and our data has 2 inputs. Our data has 2 inputs. You see here that in the first step, we are selecting the initial cluster centers. Okay, we have selected A1, A4, and A7 as the initial cluster centers. Cluster 1, cluster 2, and cluster 3. Okay, in the next step, we are calculating the distance between the data and the cluster center. For example, in A2, this is the data 2 and 5. And you see This is the distance between A2 and cluster center 1, A2 and cluster center 2, A2 and cluster center 3. These are the distances. How do we calculate this distance? Using the Manhattan distance. Okay, the Manhattan distance is like this. Let me write it for you. Okay, this is the Manhattan distance. A1 minus B1 absolute value plus absolute value A2 minus B2 plus absolute value A3. Okay, uh, okay, 1, 2, 3, n is the dimension of our data. N is the dimension of our data. Okay, so we are calculating the absolute value of the difference in each dimension. For example, if we want to calculate the distance between A2 and cluster center 1, okay, it would be like this. A2 and cluster center 1. It would be like this, okay? Let me write it for you. 2 minus 2 plus 5 minus 10. Okay, this would be the distance 5. 5 is the distance here. This is 5. Okay, you see it here. We could calculate the distance using this formula. Okay, do you understand the problem? Okay, so after we have calculated all of the distances, we update the cluster centers, and these are the new cluster centers. Okay, cluster center of cluster 1, 2, and 3. Okay, K means it has some problems. The first problem of K means is that it is dependent uh, to uh, the initial clusters. Okay, K means is dependent to the initial clusters. This is the first problem of K means. Uh, it means that if we have different initial cluster in the first step, the result of the algorithm would be different. The result of the algorithm would be different. This is the first problem. And the second problem is selecting the suitable K. Selecting the suitable K. This is the second problem of K-means. We don't know what is the best number of clusters. Okay, we don't know what is the best number of clusters. So selecting K is difficult. So these are two problems of K-means. Okay, but all of these problems they have solutions. Okay, there are many different solutions in the articles that they have talked about this. Okay, uh, for example, for the first problem, uh, selecting uh, the initial clusters, sometimes we use some evolutionary algorithms, meta-heuristic algorithm like genetic and PSO. Okay, we use this algorithm to find the initial cluster for k-means. This is a solution for this problem, and also for selecting the best k. We could select the best k using trial and error. Trial and error. Okay. Trial and error means we select the k, we test we see the result, and if it was good, we say that this k is good. Okay. Okay. Have you selected? Have all of you selected the title of your paper for presentation? Okay. I will uh, put I will put the time of the presentations in the Darsa site. Okay, I will put the time of the presentations in the Darsa site. It will be in the final sessions we will have. So I will put it there. I will check that how many students are in this class, and based on that, we will have the presentations. Maybe each of you can speak 5 minutes about their uh, paper and explain their article in 5 minutes. I will tell you about the presentations. So I will put it in the Darsa site, the time of the presentations. Yes, yes, you should. Okay, you have put the titles. That's very good. You should get the file. Okay, you should get the file of your article. Okay, and start reading. Okay, start reading the article. So you are ready. You are ready for presentation. Maybe the presentation will be maybe in the next month. In uh, this month in Iran is the ninth month, Azar. Okay, the next month is day in Iran, and the presentations will be in next month in day, and I will tell you when. But you should be ready. You can download uh, the, your article and start reading the article. Okay, and then I will tell you uh, how and when would be the presentation. Okay, I will tell you how and when the presentations would be. So, so now you could download the article and start reading. No problem. You can, if you put the address, no problem. I will tell you if you need to have a PowerPoint. Okay, I will tell you soon. I will tell you soon. Okay, that how we will have the present. Let me check how many students are in this class. I will check it right now. Okay, and let me check this. Okay, there are 40 students. There are 40 students in this class. So uh, if each of you have 5 minutes, Uh, okay, would be, um, okay, I will. Uh, okay, we should put two sessions. I will put two sessions for the presentation. Okay, we will have two sessions only for presentation, and each of you has 5 minutes for presentation. Uh, okay, I will give you the time of your presentation. It would be the two last sessions, but maybe okay, the two last sessions maybe we put some additional session. Okay, uh, for it. So I will give you the time. Each of you would have 5 minutes. Okay, each of you would have 5 minutes to talk about your paper. Yes, I will give you the list. The second course, Mrs. Hoda, what do you mean? The second course? Yes, yes, only presentation. Okay, only presentation, and then I will ask you maybe one question. Okay, uh, so you should in your presentation. Okay, you have to uh, talk about your article for maybe 5 minutes or less. Okay, less than 5 minutes. About 5 minutes, and then I will ask you one question about that. In the 5 minute, you say the title of your article and you give a very short description of what is the idea. Yeah, I will, yeah, no, no, f- first, first duty, no. You have a present, okay, you have sent your article title, okay, okay, let me show it to you. Let me show it to you. Can you see my page? Here, presentation, okay? This is the presentation, okay? All of you have sent your titles, okay? Maybe some haven't title. Send your title here. Be ready for the presentation, okay? Be ready for the presentation, okay? Your presentation would be about 5 minutes. 5 minutes, okay? 5 minutes, and you could prepare. Uh, okay, in this 5 minutes, you can prepare a PowerPoint, a very a small PowerPoint about your article, the title of your article, uh, a very short description about your article. This article is talking, okay, very short, in 5 minutes, and then I will ask you one question. This would be the presentation, okay. Uh, I will put a link for you to send your PowerPoint, okay, to send the PowerPoint of should be very short. Uh, a, you should PowerPoint in format. Put your PowerPoint in PDF format, okay, PDF, and send the PDF file. I will put a link for you to send of your presentation, okay. So very short presentation, maybe 5 slide, 5 slide, yes. Okay, you just in this 5 slide, or just want to give a summary of your article about, okay, the applications, very short, and then I will ask you one question. I will put a link for you to send PowerPoint, and as I told you, send it in PDF format, only PDF. Yes, I will put a link in there. Okay, let me put it right now for you, so you could send your uh, article here. Okay, let me put it here for you so you can send it. Okay, I put this link for you. Okay, here, send presentation PDF file. Okay, okay, you could send your presentation PDF file here. Okay, no problem. And each of you will have 5 minutes. 5 minutes to explain, very short, and that PDF file is okay. So you could send it here, and I will send the time of the presentations. Okay, I will send you the time of this. I will send you. I will send you the time of the presentations. Okay. One of the times would be maybe in this session at 11 of day. Okay, 11 of day is one of the presentation times, but we will have one more time, two sessions. Okay, we will have two sessions for presentation. Then on this date, I will tell you the next. Okay, okay, maybe we will have an additional class for the. Okay. Yes, 11 day is the last session. Uh, no, no. Uh, you will have time to send your PDF, but no. Your presentation would be okay. One of the sessions for presentation would be 11 of day, and the next one would be a day near that day. Okay, I will tell you when it would be. Maybe okay in the same week, maybe. No problem, Mrs. Hoda, if you change the article, no problem. No, not 13 day. Okay, not 30 of day because it is late. Uh, okay, it is late, and the final exam uh, would be in these dates. Okay, it would be very sooner. Maybe in the same day, or maybe okay, 1 or 2 days after 11 of day. I will tell you. Okay, I should check with the classes. I should check with uh, the class management of the university, and then I will tell you which would be the date. Okay. Okay. Have a 5 minute break, and I will be back after 5 minutes. Thanks. Okay. Do you have my voice? Okay. The next subject that we will have in clustering is hierarchical clustering. Uh, Hierarchical clustering is another type of clustering. In this type of clustering, uh, we have a distance matrix. Distance matrix. The distance matrix is the distance between the data. Okay, the distance matrix is uh, a matrix which contains the distance between the clusters. So, distance matrix is a very important concept in hierarchical clustering. It is the distance between the clusters. In this type of clustering, we don't need to determine the number of clusters. You remember in k-means, we said that we have to say what is k. K is the number of clusters. But in this type of clustering, hierarchical clustering, we don't need to determine the number of clusters. Okay. In this type of clustering, we have a tree of clusters. Okay, we have a tree of clusters. Uh, it is something like this tree. In this tree, the root of the tree is all of the data. It is inside the cluster in the root. And the leaf of the tree is the clusters which only contain only one data. So if for example, if we have 100 data, okay, we will have 100 clusters in the leaves, okay, and we will have one cluster in the root, and then these the clusters that are between the root and the leaf, they are built, okay, uh, using an algorithm. Okay, so these are the three important points about hierarchical clustering. The first one is the distance matrix. It is the distance between the clusters. Okay, we should have it. And then that we don't need to say how many clusters. And we have a tree of clusters. The important thing is how do we build this tree? The important thing is how do we build this tree? How do we build this tree in the hierarchical cluster? Okay. Uh, in hierarchical clustering, we have uh, two types of algorithms. One type of algorithm is named agglomerative algorithm, In this type of algorithm, the tree of clusters is built from the leaf to the root, bottom up. Okay, we start from the instances from the data and we combine them into some clusters until we come to the root cluster. And as I said, the root is a cluster that contains all of the data. Okay, do you understand? The second type of clustering algorithms is divisive. Divisive, it is the opposite. We are building the tree of clusters using from the root to the leaves. It is a top-down process. It is a top-down process. And the clusters are divided from the root until we reach the instances. These are two types of algorithm in hierarchical cluster. And we will talk about this one. In this slide, we will talk about this type of algorithm, which we will build the tree of cluster from the leaves to the root, bottom up process. Okay. Uh, in the agglomerative algorithm, we assume that each instance is a cluster. We assume that each instance is a cluster. This is the first thing. As I said, uh, each of the data, okay, for example, if we have 100 data, each of those data are a cluster. And we get the distance between these data. And that is the distance matrix. Okay. In the first step, the distance matrix is the distance between these 100 data. Each of our data is assumed to be one cluster. Okay, a cluster with only one data. And we get the distance between these data, and that is the distance matrix. These are the first steps in the agglomerative algorithm. Do you understand? Okay, and this is the algorithm. This is the algorithm here. Uh, Again, we have a loop, the same as k-means. Here we have a loop. Okay, we find two clusters which are nearest. We find two clusters that are nearest to each other using the distance matrix. Using the distance matrix, we find the two of the clusters that are nearest to each other. And we combine them into a new cluster. And then we have a new cluster here. Okay, we have built a new cluster using the two clusters that are nearest to each other in the distance matrix. And then we calculate the distance of this new cluster with all of the previous clusters. And we add it into the distance matrix. Okay, we repeat these steps until we come to one cluster, which is the root cluster. We said we want to build the cluster tree from the leaves to the root. So these are the steps that we will go to build the tree cluster. In each iteration of this algorithm, we are selecting the two nearest clusters in the distance matrix. We combine them into the new cluster, and then we calculate the distance of the new cluster with all of the previous clusters, and we add it to the distance matrix. We do this until we come to one cluster. Is the new distance account? Uh, yes, we will. Uh, the new distance is only for the new cluster. Okay? Okay, we have some clusters from before, and we have a new cluster. Okay, we should only calculate the distance of the new cluster with the previous ones. Okay, and we add that to the distance matrix. Okay, thanks. I will talk about this algorithm with some example in the next session. If you have any questions, please ask. Thank you very much and have a good time. التماس دارم.